So far we've looked at the definition of sustainability, and then we've looked at some industry issues and some impacts. Then we had a look at life cycle analysis. And in this lecture, we're going to look at other environmental design strategies. And then we're going to move on and just look at a few other concepts. So many designers and manufacturing companies recognise the need to reduce the impacts of the products they design and make. Indirectly, consumers and governments put pressure on companies and reinforce positive environmental change to product design. There are a number of terms that indicate a similar environmental approach to design. For example, life cycle thinking is similar to life cycle analysis that we've already looked at, but is more general in approach and arguably is a little bit more accessible as well. So life cycle thinking considers the impacts and looks at implementing strategies to minimising any impact through all stage of the product life. And that's as the same as life cycle analysis. That's where we're looking at the sourcing of the materials, the manufacture of the product, transportation, how it's used, and ultimately how it's disposed of. Designers who use an eco-design approach implement specific strategies that minimise environmental impacts. Now we'll look at some common strategies, and these are common to regardless of the material that we're using. And then later on, we're going to look at some of these again, but from a perspective of timber. So common to all of these approaches are practical strategies for design and production, and they include sourcing sustainable materials that have minimal environmental impact, ensuring that none of the materials are toxic or create toxic byproducts. So for example, some manufactured boards from the timber perspective have some glues or fillers in there which do not biodegrade well in landfill. Reducing the amount of material used in the product without lessening its ability to function, and that's known as dematerializing. Reducing the transportation distances as much as possible. For example, using locally sourced and processed materials, retailing locally, etc. And there's that concept of fuel miles in that. Reducing waste in any form, so whether it's materials, energy, pollution, and byproducts. Designing for disassembly, DFD, to be taken apart easily by simplifying and reducing the number of materials used in a product, enabling the materials to be separated easily at the end of the product's life for recycling, and labeling materials, and this is especially true for plastics, for ease of recycling. You can see in the background image there, it's an example of a furniture collection, which is actually designed specifically for ease of assembly and disassembly. Extending the product's life by increasing durability, enabling the product to be serviced and repaired easily, enabling broken or worn parts to be replaced easily. Increasing the efficiency of the product so that it doesn't use as much energy to operate. Ensuring that the materials from which the product is made are obtained from environmentally, ethically, and socially responsible sources. Developing systems and schemes for the reuse and recycling of parts and materials. So now let's just look at some specific strategies for wood, and these all relate to the common strategies that we've just looked at. So firstly, materials. So reducing the range of materials used, so that's for ease of recycling. Reducing the amount of material used without compromising strength and safety, so that's dematerializing. Using renewable, recycled or recyclable materials. Minimizing the use of timber products that use formaldehyde binder, and that's, MDF is a good example of that. Excluding solvent-based or hazardous glues and finishes. And selecting timber from sustainably managed forests. And we've looked at some of the frameworks there where we can ensure that we are doing that. Designing for disassembly, So in that example on the previous slide, in that particular case, that the products there could be both assembled and disassembled without using adhesives. Use different techniques for that. So designing for disassembly, not gluing different materials together. Production. Minimising waste, reducing the number of components from different species or materials, simplifying construction to reduce energy use, or using renewable or green energy, eliminating toxic waste. And the use of the product. So we can design it to function well, so for durability and the ability to be repaired and maintained for a long life. Recycling. So use of appropriate symbols for materials, making sure materials can be separated easily and without cross-contamination. Avoiding the use of composites or laminates, reducing fitting and parts for ease of disassembly, establishing systems to recover materials. So now we're going to look at some additional environmental design frameworks, and then we're going to go on and look at a few concepts. So environmental design frameworks and concepts help designers and manufacturers to develop strategies to minimise their environmental impacts. Now, apart from life cycle analysis, which we've already discussed, they include design for disassembly, EPR, which is extended producer responsibility, product stewardship, and C2C, which is cradle to cradle thinking. So we discussed briefly cradle to grave, but cradle to cradle is an extension of that paradigm. Now, these frameworks can be explored in more detail by reading pages 358 to 360 in the text, and I would encourage you to do so. So now we'll look at some concepts. So we've got this concept here of upcycling. So we talk about recycling. In any case, most recycled materials are made into new materials of lesser quality. Each round of recycling reduces the quality and usefulness of the materials, and this can be termed downcycling. Upcycling is where the byproducts and materials, including waste materials, from existing products are reclaimed for better value. It saves wastage and reduces the need for new materials and other resources, such as air, water, and energy. Resulting products can be of better quality, higher value, or more use. Upcycled products that have been handcrafted from recycled materials are usually more valued by the owner than the original product and are kept in use for a longer period of time. And a good example of this is things like hardwood fence palings. They were a lot more common in the past when, hardwood for fences was, much cheaper than it is now. But today, as those fences come down, that material can be reused, and there are plenty of designers out there that use materials like that to create furniture and other items, which are actually arguably more valuable than the original product. Embodied water. Embodied water does not refer to the amount of water present in a product. It is a way of quantifying the amount of water used in creating and processing the product's materials and in the production of the product. For example, the embodied water of a t-shirt would include the water used to grow the cotton, clean it, and dye it. And, as an aside, a 500-gram shirt embodies approximately 4,100 litres of water. Embodied energy. The embodied energy of a product refers to the amount of energy used to source and process materials, produce and transport the product, and dispose of the product. It is usually measured in megajoules per kilogram of product. Embodied carbon is the amount of greenhouse gases released into the atmosphere as a result of creating a product and is often related to the amount of energy needed to source, make, and transport the product. It is measured in tonnes of CO2 per kilogram of product. However, the amount of greenhouse gases created by a product and its embodied carbon may be reduced if the source of energy used is not a fossil fuel. For example, it is solar, wind, thermal, hydro, or nuclear power, and there is minimal transportation involved. Greenwashing is a negative term, indicating that an organisation is trying to gain green or environmental credibility without deserving it. An organisation might create the impression that a product, a service, or their brand is environmentally responsible when it's not. For example, by deceptive packaging, manipulative or selective use of data, or meaningless green certification. Or it might focus on a small positive action of the organisation in an effort to distract attention from larger negative impacts. And the actions of some of the oil companies are a good example of these. Greenwashing can mislead consumers about a product's attributes or an organisation's environmental practices in terms of sustainability. Unfortunately, this tends to make consumers suspicious of all sustainability claims.